Welcome back to another video. Dr. Tarcia Huber here. And in this video, we're going to talk about some more new identities, the sum and difference identities, this time for sine and tangent. If you watched the last video, we talked about the sum and difference identities for cosine. And so we're just going to jump right in. I'm going to show you what those identities are and show you how to use them, okay? So first, the sum and difference identity for sine. It's kind of similar to cosine, except there's a few things that's different, all right? First of all, the sine of two angles being added is equal to the sine of the first times the cosine of the second, plus the cosine of the first times the sine of the second, and vice versa. If you're subtracting two angles, it's the sine of the first times the cosine of the second, minus the cosine of the first times the sine of the second. So let's notice what's different here than the cosine one. So this time, notice that the signs stay the same. So if you're taking the sine of two angles being added, you will still add when you break it apart. And then the thing that's different also is that the functions switch. So with the cosine of two angles being added, it was the cosine of the first times the cosine of the second. This time it's the sine of the first times the cosine of the second. So you're mingling the sine and cosine when you multiply. Before you were multiplying both cosines and both sines together, if that makes sense. Alrighty, so these are your sine, sum and difference angle identities for sine. Let's look at tangent. Now, tangent is completely different. So if you want to take the tangent of two angles being added, this time it will be the tangent of the first plus the tangent of the second divided by 1 minus the tangent of the first times the tangent of the second, and vice versa. The tangent of two angles being subtracted, it would be the tangent of the first minus the tangent of the second over 1 plus the tangent of the first times the tangent of the second. So let's notice a few things here. If you're adding two angles, then you're going to add the tangent of each of those angles in the numerator. But you're going to do the opposite sign. You're going to do 1 minus the product of the tangent of those two angles in the denominator. If you're subtracting two angles, you're going to do the difference. So that sign is going to stay the same in the top. The difference of the tangent of those two angles in the numerator. And then you're going to do 1 plus, so the opposite sign of those two, the tangent of those two angles, the product of those two angles, okay? So now let's look at some examples involving these identities. So we want to find the exact value of sine of 75 degrees. And again, these identities are good for finding the exact value because we can use our special angle. So I know that sine of 75 is the same as sine of 75 degrees. Is the same as sine of 30 degrees plus 45 degrees. All right, and so now we can use our identity. So that's the sine of 30 degrees times the cosine of 45 degrees. And the sign stays the same, so plus, and then you switch them. Cosine of 30 degrees times the sine of 45 degrees. And so now you just figure out what is that. So sine of 30 degrees is 1/2. Cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. So that's equal to the square root of 2 over 4 plus the square root of 6 over 4. And because those denominators are the same, you can combine those into one fraction and make that square root of 2 plus square root of 6 all over 4. And so that would be the exact value of the sine of 75 degrees. And that is how you would use the sum identity for sine to actually find those. So we took 75 and broke it down into 30 plus 45 because we know the sine and cosine of those angles. If you have any questions, put them in the chat, okay? Let's look at another one. So now this time we're going to find the tangent of an angle that's not a special angle. I know for a fact 7 pi over 12 is not a special angle. Again, this is radians. I like to work with degrees, so I'm going to just first convert this to degrees by multiplying it by 180 degrees over pi. And so you would do 7, the pi's would cancel. You would do 7 times 180 divided by 12, and you would get 105 degrees. So this is 105. That's a 5. degrees. I'm too close to the edge, so it won't let me fix my 5, but that's 105 degrees. So the tangent of 7 pi over 12 is equal to the tangent of 105 degrees. And I know that 105 degrees can be broken down into 60 degrees plus 45 degrees. So now I can use my sum identity for tangent. So that's going to be equal to the tangent of 60 degrees. So the tangent of the first, remember the sine stays the same in the top. So plus the tangent of 45 degrees. And then the sine switches in the bottom. So that'll be 1 minus the tangent of 60 degrees times the tangent of 45 degrees. All right, and so now all we need to do is to work that out, all righty? So tangent of 60 degrees is, if you remember, the square root of 3. Tangent of 45 degrees is 1. And that would be 1 minus square root of 3 times 1 in the bottom, which is equal to the square root of 3 plus 1, all over 1 minus square root of 3. Now remember, we cannot leave a square root in the denominator, so we have to rationalize that denominator. The way we're going to rationalize the denominator is to multiply top and bottom by the opposite or the conjugate of that denominator. So 1 plus the square root of 3. And I'm just going to come up here and work that out. So in the top, I will FOIL that out. I will do square root of 3 times 1, which is square root of 3. I will do square root of 3 times square root of 3, which is 3. 1 times 1, which is 1. And square root of 3 times square root of 3. 1 times square root of 3, which is square root of 3. In the bottom, I will do 1 times 1, which is 1. 1 times square root of 3, which is the square root of 3. Negative square root of 3 times 1, which is negative square root of 3. And negative square root of 3 times a positive square root of 3 is a minus 3. And if we simplify that, in the top we have 2 square roots of 3 plus 4. In the bottom, the square roots of 3's cancel, and we're left with 1 minus 3, which is negative 2. And so we could break this down. I'm just going to write the 4 in front. This is the same as 4 over negative 2 plus 2 square roots of 3 over negative 2. And I'm just putting the 4 in the front so that it doesn't get mistakenly put under the square root of 3. And so that gives me negative 2, the 2's cancel, minus the square root of 3. And so that would be the exact value of the tangent of 7 pi over 12. Now I know that was a lot of steps. However, it was all just plugging it into the identity and then simplifying. It was a lot of simplifying involved in that. So if you have any questions about any steps in the simplification process, then please don't hesitate to put them in the comments. Hopefully it made sense. If you don't have any questions, let's jump to the next example. All right, for this one, we want to find the exact value of sine of 40 degrees times cosine of 160 degrees minus cosine of 40 times sine of 160. I can look at this and tell that this involves the sum, either angle or difference identity. If I go back to those, you see it has the minus. It's this bottom one right here, sine A cosine B minus cosine A sine B. Well, that's equal to sine of A minus B. So this would be sine equal to sine of the first angle minus the second angle. So 40 degrees minus 160 degrees is sine of negative 120. If you think about negative 120 is going to be, so 90, negative 120 would be over here. It will have a reference angle if you did 180 minus 120 of 60 degrees. So that means this reference angle here is the 60 degrees. So it's going to share the same sign as 60 degrees. However, it's in the third quadrant, so it's going to be negative. Sine of 60 is 1/2. No, Sine of 60 is square root of 3 over 2. So it'll be negative square root of 3 over 2. So the answer to this will be negative square root of 3 over 2. Let me know if you have any questions about it. If not, let's go to the next one. All right, and so this is the last example we'll do in this video. Here, we're just going to go back to verifying identities. And so now we can verify some new identities because we have some new identities to use. And so we start with the most complicated side, and we also see that we can use the sum and difference identities for cosine. So we're going to start with this side, sine of pi over 6 plus theta plus cosine of pi over 3 plus theta. Remember, we start with the most complicated side, and we use that to simplify it to get to the other side. So I'm going to use this sine, the sum angle identity for sine here. So sine of pi over 6 plus theta is going to be sine of pi over 6 times cosine of theta plus cosine of pi over 6 times sine of theta. All right, that's the first one. Then we have a plus in between there, and then I'm going to use the sum identity for cosine for this second one, which is going to be cosine of pi over 3 times cosine of theta, and I'm going to run out of room, so I'm just going to write it underneath here, and that's a 3 in the denominator, and that's going to be minus sine of pi over 3 times sine of theta. That's a sine of theta at the end, y'all. Okay. And that's in parentheses as well. So now I'm just going to reduce that. So sine of pi over 6. So pi over 6 is the same as 30 degrees. The sine of that is 1/2. So that's 1/2 cosine of theta. Cosine of pi over 6. That is square root of 3 over 2 sine of theta. And then plus cosine of pi over 3. Pi over 3 is the same as 60 degrees. So that's 1/2 cosine of theta. And then minus the sine of pi over 3. The sine of pi over 3 is square root of 3 over 2. So that'll be square root of 3 over 2 sine of theta. Now, if you notice, we have a positive square root of 3 over 2 sine theta and a negative square root of 3 over 2 sine theta. So those would cancel. And that would leave you with 1/2 cosine of theta plus 1/2 cosine of theta. And that equals to 1 cosine of theta, which we'll just write cosine of theta, which is what we were trying to show. We were trying to show that this equals the cosine of theta. And we've done that. We've proved that. And so that would be our verification of that identity. And of course, you will need to justify each step. The first step is using the sum identities for both sine and cosine. The second one is just simplifying. And the third one is just simplifying. And the fourth one is just simplifying as well. So if you have any questions whatsoever about how to verify identities using the sum and difference identities, then please put your questions in the comments and I will respond. If you found this video helpful, go ahead and hit the like button. And if you haven't already, go ahead and subscribe to the channel. And I will see you all in the next video. Thanks for watching.